Okay, now we're working on 7.2, number 11, and this is partial fraction decomposition. The problem already gives you all of this and breaks down your A and your Bx plus C, but I do want to talk about why you have a Bx plus C in this case. So as long as you always look at your denominator, so your denominator has two factors. So we know that we're going to have two fractions, one for each factor. Now this is x plus 4. If you want to think of it, it's x to the first power. So as long as you have just an x and that's it, you'll only have one letter, in this case a. This x squared plus 9 cannot simplify anymore. It's not the difference of two squares, because the difference of two squares means that you have a minus sign in the middle. When you have a plus sign, you cannot factor this at all. This is as simple as it's going to get. So when you reduce your factor to simplest terms, and it still is an x squared, you have to put an x plus a letter. In other words, this might be a 5x plus 3. It might just be a 3. We don't know yet. But if this is an x squared on bottom, there's a good chance that there'll be an x, a power down by 1. This is x to the second, that's x to the first. There's a good chance that you'll have like a 5x plus 2 or something like that. We don't know. So whenever you have just an x, you just need a letter. If you have an x squared, you need a bx plus c. If you want to do dx plus f or something like that, it doesn't matter, but it has to be a letter to represent the coefficient in front of your x plus just a constant that's by itself. Now the first thing that we need to do is figure out what our A, our B, and our C are. So we already have our fraction. So what we're going to do is we're going to multiply every term. What I'm going to do also, I don't like this little minus sign. They haven't factored out. I'm going to distribute that minus sign to all terms. So that's going to make this a negative 4x minus x minus 40. I'm going to write that in my next go round. Also, what we want to do is we want to multiply all three terms by the denominator, by x squared plus 4 times, by x plus 4 times x squared plus 9. So if I could kind of squeeze it, x plus 4 times x squared plus 9 over 1. Now, just pretend I'm writing this term 3 times. This is going to multiply to all 3 terms. Now, what we're doing is we're simplifying our fraction. So when this multiplies, the denominator cancels. When this term multiplies to the a term, the x plus 4 cancels, but the x plus squared plus 9 shows up. When we take the long term and multiply it to the bx plus c term, the x squared plus 9 cancels, but we have an x plus 4 show up. So when we rewrite this, I'm distributing the negative, and I'm writing it in with no longer having a denominator. We get a negative 4x squared minus x minus 40 equals a times x squared plus 9 plus bx plus c times x plus 4. Now what we want to do in this situation is we want to start figuring out what our A, B, and C are. So we have 3 letters, 3 terms, 3 variables. They're not variables. They actually represent constants. We have 3 terms that we want to figure out. That usually means 3 equations. So for each term that you're looking for, you need its own equation. So we're going to have to go through a process 3 times. And we want to find a term for x so we can start canceling things out. let's see, we have a bx plus c times, well, that x squared is not going to be, well, here, I'm going to let x equal a -4. And the reason why I'm doing that is I'm looking at this term right here. If x is a -4, then what that gives us is a -4 plus 4, and that equals 0. So that means this whole term, bx plus c, whatever that is going to equal 0. So that's a -4 times -4 squared minus a -4 minus 40 equals a times a -4 squared. I'm putting parentheses around the -4 because without the parentheses, the power of 2 would go to the 4 but not the negative. With the parentheses, it's indicating that this is not a 4, that this is a -4, so that the power of 2 goes to both the negative and the 4, plus 9. All this is 0, so don't need to worry about that. A -4 squared is a positive 16, so we have a -4 times 16 plus 4 minus 40 equals a -4 squared here, that's a positive 16 plus 9, so that's going to be 25. The great thing is, if you look at this, a is the only unknown in this equation, so that means we'll actually be able to figure out what a is. Sometimes you have to just make do with an equation in the beginning and come back to it later. So from here, we have a -4 times 16, so a -4 times 6, I'm going to move this up a little bit. It's a -24. 4 times 1 is 4 plus 2, that's a -64. A positive 4 minus 40. Now when you're subtracting, you always keep the sign of the bigger number. The minus 40 is bigger, so and it's negative, so we're going to keep the negative. So that's going to, so if you want to think of it as a 40 minus 4, and then keep the negative, if you like that better. Minus 36. Hi, kitty. Yeah, good boy. Good boy. And that's my kitty. All right, so then, now notice they both have the same sign. So this is a -64 minus 36. So that means they're both going the same direction. They're both decreasing. In other words, the numbers are going to add, but you keep the sign. So 6 plus 4 is 10. Carry the 1. 6 plus 3 is 9, which is 10. But this is a -100. So we have a -100 equals 25a. So then from here, so all this is -100, divide both sides by 25. 25 divided by 25 is 1. So what we get, a -100 divided by 25 is a -4 equals a. So this is going to be nice. Come back to that. But also when we go back to our equation, because we're going to come back to this equation again, is now we can actually plug in a -4 here, and that's going to make finding b and c easier. So going back to, we're going to repeat the process. So we have, I think I'm going to stick that minus sign back in. I'm going to try that. Sometimes it is a good idea. I normally like to take it out. 4x squared plus x. So in other words, I'm going back to the beginning where, just like they gave it to us, where they had the negative sign factored out. I'm going to try that and see if I like that way better, instead of having it distributed. See if that's going to make finding the B and C easier. This is an X, by the way. Equals. So we knew that our A was a -4. So we have a -4 times x squared plus 9, and then plus Bx plus C times x plus 4. So we're going to look in here and see, now Bx plus C, this one's going to be hard to really get rid of 1, because if we get rid of 1, we probably get rid of both of them since they're both in the same term. So what might be a good decision here is, how can we come up with an equation that would be simple to work with? It might not give us the answer immediately, but we'll be able to use it to get the answer. So from here, let's let x equal 0. That's always a good place to start. So when you're trying to reduce or come up with a good equation and you don't know what to do, this is a good default. It'll definitely give you something helpful. So if we let x equal 0, we're going to plug this in. That's going to be a negative 0 plus 0, that's going to be 40, equals a -4 times 0 plus 9, plus, oh, this actually is going to work because this is going to be b times 0, so this is going to go to 0. But the c won't, and then that's going to be 0 plus 4. So then what that gives us is a -40 equals a -36 plus 4c. Then from here, add 36 to both sides. So a -40, if this is negative and this is positive, we know we're going to subtract because the signs are opposite. But you want to keep the sign of the bigger number. 40 is bigger than 36. Since 40 is negative, we're going to keep the negative sign. 40 minus 36 is 4. So -4 is the answer, equals 4c. From here, divide both sides by 4. A -4 divided by 4 is a -1, equals c. So that works out nicely because now that we have A and C, finding B should be a lot easier.